Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. If y equal to cos inverse of x the whole square, then prove that 1 minus x squared into y double dashed minus xy dashed minus 2 equal to 0, right? So we know that our y double dashed is nothing but dy dx of dy by dx, and then our y dashed is nothing but dy by dx, right? So we will have to start off by arriving at y dashed for this particular problem. And I'm not going to do this by the method of substitution, though that we have a cos inverse function. I'm going to apply the chain rule to arrive at my y dashed, but directly using derivatives of cos inverse from first principles. Okay, so I have square function. From chain rule, I differentiate my square function first. So I get a 2 times cos inverse of x. And then I differentiate my cos inverse of x, which is nothing but a minus of that. So 1 divided by square root of 1 minus x square, right? Now I also need to establish what is my y double dash, right? So let me write down my y dash first. Now I go ahead and start off with my y double dash, right? So this is my expression. I know that I can keep minus 2 side and differentiate my cos inverse of x the whole divided by square root of 1 minus x square, right? So I have a function of the type f of x by g of x. So therefore I will apply quotient rule. Let me open my bracket. And when I apply the quotient rule, what is my step one? My step one is to square the denominator. And when I square the denominator, I get a square of square root of 1 minus x square, which makes it 1 minus x square. And then I go to my numerator. I retain the denominator as it is. And then what do? I differentiate my numerator first. And what is my numerator? My numerator is cos inverse of x. And what is d by dx of cos inverse of x? We've already done this in step 1, which is nothing but minus 1 divided by square root of 1 minus x square, right? So this is my first part of the numerator. And then I have a minus of, what do I do next? I do a d by dx of square root of 1 minus x square, right? So let's write that down because looks like we have to do this in two steps. Into, I retain the numerator as it is, which is my cos inverse of x, right? I have a 1 minus x square in my denominator. And then my first part of the numerator, which is a root of 1 minus x square into minus 1 divided by root of 1 minus x square, my root term gets cancelled and I'm left with a minus 1 minus of cos inverse of x, right? And now I have a d by dx of square root of 1 minus x square, right? What do? We have a square root function. Therefore, I apply the chain rule because we have a square root function and then we have a 1 minus x square inside the square root, right? So what is that? It's nothing but 1 by 2 times square root of 1 minus x square, because my d by dx of a square root function is nothing but 1 by 2 square root, right? Which means d by dx of square root of x is nothing but 1 by 2 root x. So I do that, and instead of x I have 1 minus x square. Then when I apply the chain rule, I go into my function inside the square root, which is 1 minus x square, and I differentiate that with respect to x. And what do I get? Minus 2x, right? Now I know that I can cancel out the 2 here. Let me highlight it in yellow. The first part of the numerator is a minus 1. And then in my second part, I I have cancelled out my 2 and I have two negative signs. So I turn them into a positive sign and I have nothing but x times cos inverse of x divided by square root of 1 minus x square, right? Can I have highlighted this in green? Can I draw a parallel to one of my earlier workings? The answer is yes, right? So what is this? My y dashed, right? And what is my y dashed? Is minus 2 times cos inverse of x divided by square root of 1 minus x square, right? What is my cos inverse of x divided by 1 minus x square here? So let me copy this here. This expression is nothing but minus of y dashed by 2. Right? This expression cos inverse of x divided by square root of 1 minus x square is nothing but minus y dashed by 2. Right? And that is what I'm going to do in the next step. Y double dash is equal to minus of 1. Let me highlight this. Minus of 1 plus x times minus y dashed by 2. Right? Based on the working that we did just now. So what happens to this is minus xy dashed divided by 2 is what we get here, right? And then I have a 1 minus x square in the bottom, right? And remember, folks, I still have my minus 2 out here. And therefore, my y double dashed is minus 2 times and minus 1 minus xy dashed by 2 whole divided by 1 minus x square, right? And I know that I can pull out the minus sign and write this as something like this, right? So this is what I get. Now I'm going to move my 1 minus x square to the left by cross multiplication. And I think we have more or less arrived at what we want to arrive at, right? So I have a y double dashed into 1 minus x square equal to 2 times 1 plus xy dashed by 2. Right? And my LHS can further be simplified. I can write this as 2 plus xy dashed means when I move all the expressions on the right, which is a 2 plus xy dash to the left, I get what I want, right? Y double dashed into 1 minus x square minus of xy dashed minus 2 equals 0 and hence proved, right? So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.